Hey everybody, so today you're going to spend some time getting ready for your first quiz in Unit 6. Before we get started, this chapter has a lot of work with simplifying radicals, so I would suggest that either you take out notes number 1 or across the top of your page, make a list of your perfect squares. So to make a list of perfect squares, you can quickly figure them out, like you do 2 squared to get 4, 3 squared is 9, 4 squared is 16, and so forth. And just keep listing them: 25, 36, 49, 64, 81, 100, 121, and you can stop at 12 squared, which is 144, okay, because they do get pretty big pretty quick. All right, so remember that when the directions say to simplify, it means no decimals. So my friends, if you just jump to your calculator and start typing in like the square root of 96 and you give me a decimal for an answer, it's just plain old wrong. Wrong. No credit. Nothing. Nada. So you've got to simplify. So you've got to use the rules for simplifying radicals. So keep in mind that you want to go for the biggest number. So when you take the square root of 96, you can try dividing 96 by 4. You'll find that it works, but you want to go big. So actually 96 factors into 16 times 6. 16 is the largest perfect square that divides into 96. And when you take the square root of 16, you get 4. The 6, though, is left inside the radical. So final answer is 4 square root of 6. Okay, number 2, the square root of 108. Again, no decimals. Don't go to the calculator and just type it in and write down the decimal for me. So 36 is also divisible by 4, but if 4 works, I want you trying 16 and 36, and actually 36 is the magic number for this case. So 36 times 3 will give us 108, and the square root of 36 gives us 6 on the outside. Again, this number stays inside the radical. Okay, now we're stepping it up a bit. We have a number on the outside already, and that's going to get multiplied by anything that we bring out. So you have your 3, and then you want to factor 27 into 9 times 3, because 9 is a perfect square that divides into 27. So we're going to have 3 times 3, and then we're left with this 3 inside. Final answer then is 9 square root of 3. Okay, so for number 5, we've got 5 square root of 45. 9 is also the perfect square that divides into 45, and it goes 5 times. So we have 5 on the outside. It gets multiplied by whatever you bring out. So it becomes 5 times 3, square root of 5. Again, this 5 stays inside. Final answer then would be 15 square root of 5. So watch out for common mistakes. Decimals are a common mistake. Also, adding the numbers out in front is a common mistake. You want to make sure you multiply. All right, let's try a few more. Okay, so the perfect square is handy. In number 5, we're going to take the square root of 10 times the square root of 6. So in this case, you want to actually do 10 times 6 and make it 60 on the inside, because neither 10 nor 6 is a perfect square. And we want to divide 60 by 4. I know I always tell you to go big, but nothing bigger than 4 divides into 60. I mean, no perfect square bigger than 4 divides into 60. So final answer for this one is 2 square root of 15. Okay, I'm not loving the green. I'm going back to blue. So number 6, 20 square root of 15. Multiply the 20 and the 15 together to get 300. So anytime it's a multiple of 100, that's what you want to use. So factor 300 into 100 times 3. The square root of 100 gives you 10 on the outside. That 3 stays on the inside. So 10 square root of 3. Final answer. Okay, and the next one, it's a little different. We cannot add these two together because they're not like terms. So if you do something crazy, I'm just going to put not equal and the word no here. If you do something crazy like writing 5 square root of 39, then we have to talk, okay? You cannot just come in and add those two together. This is really bad, okay? You can only add radicals, but they're like terms. So we need to simplify. So take that square root of 12 and rewrite it as 4 times 3. And then take 2 square root of 27, rewrite the 27 as 9 times 3. So we have 3 on the outside here. And we're going to have a 2 on the outside too, because the square root of 4 gives me 2. And we've got 3 on the inside. Over here we've got 2. And now the square root of 9 gives us a 3. It's going to get multiplied by that 2. And this 3 is also left inside the radical. So 3 times 2 gives us 6 square root of 3. 2 times 3 also gives us 6 square root of 3 here. They are like terms, not because of the 6's, but because of the square roots of 3. So now we can add them together, and we have a total of 12 square root of 3. Final answer. Notice that the square root of 3 did not change when we are adding. So addition and subtraction is not going to change the radical. Okay? Okay, number 8 is kind of similar to number 7 in that we have to simplify first before we can add. So 54 factors into 9 times 6, 9 being the perfect square, and 24 factors into 4 times 6. Okay, just like on the last one, we kind of have a clue. Since I'm left with a 6 in the radical for the first case, you also want to have a 6 in the radical for the second one if they're going to be able to be added together. Okay, so that can kind of help you to figure out how to simplify something. All right, taking the square root of 9 to give us 3 square root of 6. Over here you have 2, and then the square root of 4 is 2 square root of 6. So we've got 3 square root of 6 plus 4 square root of 6, and that's going to give us a total of 7 square root of 6. You can also say 7 radical 6, whatever works for you. Okay, in 9 and 10, the problems with these two are that they have radicals in the denominator. So what we do is called rationalize the denominator. That's where you multiply both the denominator, which is the bottom, and the numerator, the top, by something. Okay, and to figure out what that something is, you have to take a look at if you multiply these two together, they have to become a perfect square. So that's why we wanted to multiply by the square root of 2, because the square root of 2 times the square root of 2 becomes the square root of 4. On the top, the square root of 5 times the square root of 2 is the square root of 10. And then this simply would become the square root of 10 over 2. Final answer. In number 10, I want you to take a look at that numerator really quick. You see that 4? See what's inside a radical? So that's going to become 2. The square root of 4 is 2 over the square root of 3. Now, it doesn't mean that we're done, but it is going to help you save a little bit of time later on because we simplified a little bit first to make our lives easier later. Okay, now we have to rationalize and multiply top and bottom by whatever will make this denominator equal to a perfect square. So we need the square root of 3 over the square root of 3. In the top, it becomes 2 square root of 3. The denominator becomes the square root of 9. And then final answer would be 2 square root of 3 over 3. We're done. Okay, on to the Pythagorean theorem. Okay, so in this group of problems in 11 through 14, we're going to be solving for a missing side using the Pythagorean theorem. Now, I've noticed over the years in teaching geometry that once we study special right triangles, people tend to forget about just regular old right triangles and using a squared plus b squared equals c squared. So notice in these 4 problems, we don't have any information about the angles, so we've got to use a squared plus b squared equals c squared. Okay, and notice also that the directions say leave your answer in simplest radical form. And guess what? That means no decimals. Alright, so in this first one, the hypotenuse is labeled with x, so we want that guy to stand alone. So we're going to do 6 squared plus 8 squared and set it equal to x squared. 6 squared is 36, 8 squared is 64, and that's equal to x squared. 36 and 64 is equal to 100. So we want to take and do the square root of both sides to solve for x. Square root of 100 is just 10, so this one works out really nicely. Our hypotenuse is just 10. So that was nice. No decimal, no simplifying radicals either. All right, and number 12, 13 is our hypotenuse. So I'm going to label it as such. And so we want to actually do x squared plus 5 squared and set it equal to 13 squared. Remember, in the Pythagorean theorem, the hypotenuse always stands alone. So we've got x squared plus 25 is equal to 169. Take and subtract 25 from both sides, and you get 144, sorry. So you get x squared equals 144, and take the square root, and we get to x is equal to 12. So there we go, 2 in a row that had nice answers that did not involve simplifying radicals. All right, let's scoot this up a little bit. And if we take a look at number 13, again, identify your hypotenuse, and that is 13. And in number 14, x is the hypotenuse. All right, so setting up number 13, we're going to do x squared plus 9 squared is equal to 13 squared. So x squared plus 81 equals 169. Take and subtract 81 from both sides, and we'll have x squared is equal to 88. Okay, finally one we're going to have to simplify. So we take the square root of both sides, and the square root of 88, if you were to jump to your calculator, it would be a decimal. So let's find something big that divides into 88. Well, nothing really big divides into it, but I know 4 is going to go in 22 times. So final answer for this guy will be x is equal to 2 square root of 22. And I know I'm done because 22 is just 11 times 2. And I apologize if you hear like thumping in the background. My daughter, I don't know what she's doing upstairs in her room. She's jumping around or something. Okay, last one for this section, number 14. We're going to set it up as 5 squared plus 15 squared is equal to x squared. 5 squared is 25. 15 squared is 225. And that's equal to x squared. 25 plus 225 is 250. And we do need to take the square root of that. If you check it out, 250 is equal to 25 times 10. And you see that gives us a nice perfect square to take the square root of. So final answer for x will be 5 square root of 10. Done. Okay, in this next group of problems, we have to determine if the numbers that we're given, the side lengths that we're given, would create a right triangle, an acute triangle, or an obtuse triangle. Okay. So I want to have those 3 cases written down. The one that's easiest to remember is if c squared is exactly equal to a squared plus b squared, we should know that that's a right triangle. Okay, if c squared happens to be bigger than a squared plus b squared, then it's an obtuse triangle. And finally, if c squared is smaller, if it's less than a squared plus b squared, then it's an acute triangle. So you may want to have those written at the top of your paper. You know, c is always going to be the longest side. So I'm just taking a minute to circle all my values for c. If you're not sure which is biggest, then you should check some stuff out on your calculator, like with the square roots, okay? All right, so let's set it up. We're going to do 15 squared, and we're going to compare it to 9 squared plus 12 squared. So you can put a question mark here, you can leave it as a blank. 15 squared is 225, 9 squared is 81, 12 squared is 144. And so if we add the 81 and the 44 together, notice that we end up with 225. So 225 is exactly equal to 225. That means our triangle is a right triangle. All right, and number 16, we're going to have 18 squared, and we're going to compare it to 9 squared plus 12 squared. 18 squared is 324. Take some help from your calculator. We know what 9 squared plus 12 squared is. We just did it on the last one. It's 81 plus 144, which gave us 225. And 324 is definitely bigger than 225. So that was c squared greater than a squared plus b squared. So this is definitely an obtuse triangle. Okay, again, let me move this up so we have a little bit of work. I know we can't see our 3 things up above, but we'll be fine. At number 17, we want to do the square root of 11 squared and compare it to the square root of 2 squared plus 3 squared. Now the square root of 11 squared is just 11. Check it out on your calculator. When you square a square root, it just gets rid of the radical. And again, we're comparing it to the square root of 2 squared, which is 2, and 3 squared, which is 9. So you have 11 and 11. So they're equal. So this is a right triangle. So again, if c squared is equal to a squared plus b squared, it's definitely a right triangle. All right, last one. So 14 is going to go in for c. So we have 14 squared, and we're comparing it to 4 squared plus 6 square root of 5, quantity squared. And this part is going to be the trickiest part, the 6 square root of 5 squared. So 14 squared is 196, no problem with that. We're comparing it to 4 squared, which is 16, plus this guy, 6 square root of 5 squared. If you use enough parentheses, you can type it into your calculator. Okay, so you do parentheses 6 square root, which gives you parentheses inside the radical. Close both of them, and then square it. And what it does is it's going to do 6 square root of 5 times 6 square root of 5. So in other words, it's going to take that 6 and square it and get 36. And it's going to take the square root of 5 and square it and get 5. So we'll have 196 on the left-hand side. Then we have 16 plus 180. So if we know what happened here, I gave you another right triangle. 196 would be equal to 196. So we have a right triangle. So in the next group of problems, we will be using special right triangles. So remember, we have 2 different special right triangles. We have the 45, 45, 90, which you might see the 45 and 45 in there. You might just see 2 sides marked congruent. And that ratio goes x, x, and then to find the hypotenuse, you multiply the leg by the square root of 2. The other special right triangle, and I'm going to put it down by number 22, is the 30, 60 right triangle. So that's where we have a 30-degree angle, 60, and a 90. The side that's opposite the 30-degree angle is the shortest leg, so that gets the x. The side opposite 60 will be x times the square root of 3, and the hypotenuse gets 2x. So in number 19, if we take a look, this is one of the easiest ones. So we do have a 45, 45 right triangle. So the 2 legs are congruent. So those are each equal to x. So this leg has to be 4 as well. And then to find the hypotenuse, you take x times the square root of 2. So it's going to be 4 square root of 2. And please label the legs, label the sides themselves, and don't just put the numbers anywhere. I need to know that you understand which side has which length. So number 20 is a 45, 45 right triangle. So each of these would get an x, and the hypotenuse would be x squared root of 2. So if we take x squared root of 2 and set it equal to 6, we need to divide by the square root of 2 to solve for x. Now this is going to involve rationalizing the denominator. So multiply top and bottom by the square root of 2. And we get 6 square root of 2 over the square root of 4. Which is 6 square root of 2 over 2. And then you need to divide 6 by 2 to get 3 square root of 2. But if you recall, we talked about a shortcut. And I said, and we looked at lots of examples, if your hypotenuse is even, which we have here, you can take half of it times the square root of 2. So half the hypotenuse times the square root of 2. Only do that if the hypotenuse is even, though. At number 21, these 2 legs are marked congruent, so that's got to be our x value. X is equal to the square root of 10. And the hypotenuse is equal to x times the square root of 2. So we're going to take the square root of 10 times the square root of 2, which would become the square root of 20. Now that has to be simplified. So the square root of 20 factors into 4 times 5. The square root of 4 gives you 2, square root of 5. Final answer. So this hypotenuse would be 2 square root of 5. Okay, switching gears, in number 22, we're going to take a look at the 30, 60, 90 triangle for these three, actually. So in number 22, we do have the side opposite 30 degrees, so that gets x. This would be 60 at the top, so this side is x squared root of 3, and the hypotenuse is 2x. So on this side, we have 7 square root of 3, so plugging in 7 for x, and then 7 square root of 3. And the hypotenuse would be 2 times 7, which is 14. So double that short leg. Alright, number 23, not too bad. We have 30, this would be 60. Label those sides. Across from 30 gets the x. Across from 60 gets x squared root of 3. And the hypotenuse gets 2x. So this, my friends, is what's going to allow us to solve for x. Hopefully you can look at that and say, hey, x has to be 8. If you need to solve it, you're going to solve it by dividing by the square root of 3 on both sides. So you get x is equal to 8. Okay. Don't forget, label the hypotenuse. It's 2 times 8 because it's 2 times x, so the hypotenuse is 16. Okay, so we have to throw in one that's a little bit more challenging. So this guy is a 30, 60, 90. So this is x. This side, labeled with 6, is x squared root of 3. And then we have 2x. So this is what makes it more challenging. Our side that's opposite 60 degrees, we always hope that it has the square root of 3 on it already for us, because then it would be easy to solve for x. This is going to make it a little more interesting. So if x squared root of 3 is equal to 6, all we need to do is divide by the square root of 3, and then rationalize. So you have 6 divided by the square root of 3, multiply top and bottom by the square root of 3, and we get 6 square root of 3 over the square root of 9, which becomes 6 square root of 3 over 3, and that would become 2 square root of 3. Okay, that's a lot of work to solve for x. And we still have one more side to find, and that is the hypotenuse. We need to do 2 times x, so it's 2 times 2 square root of 3. The hypotenuse is 4 square root of 3. We're just doubling the short leg. Times the square root of 2. Alright, last question. It says find the area of the figure below. So we know area of a triangle is base times height divided by 2. So x plus y would be the whole base. And we're lucky. In this case, we have the height is 24. So we're partway there. So we're going to take the base, multiply by 24, and then divide by 2. So we have to solve for both x and y, and we do have a right triangle. We have 2 right triangles in here back to back. This little guy on the left is a right triangle, so we can use that right triangle and the Pythagorean theorem to solve for x. And then we're also going to have a right triangle here on the right hand side, so you can use the Pythagorean theorem to solve for y as well. So on the left hand side, this is my hypotenuse for this little right triangle that I highlighted in yellow. So we are going to set it up as x squared plus 24 squared equals 25 squared. So x squared plus 576, because that's 24 squared, and that's equal to 625. Take and subtract 576 from both sides. We end up with x squared is equal to 49. Luckily for us, that's a perfect square, so the square root of 49 just gives us 7. Okay, so x is equal to 7. Alright, we're part way to finding our base, because the base is x plus y, so it's 7 plus whatever we get for y. Alright, next we need to use this triangle that's on the right. I'm kind of highlighting in red here. We're going to use that to solve for y. In that triangle, 40 is the hypotenuse. So we're going to set it up as y squared plus 24 squared is equal to 40 squared. So y squared plus 576 is equal to 40 squared, which is 1,600, or you could say 1,600. And then take and subtract 576 from both sides. That gives us y squared is equal to 1024. Take and do the square root of both sides to solve for y. And the square root of 1024 is actually 32. So y is equal to 32. So we need to do 7 plus 32, which is 39. Okay, that's our base. So we're going to do 39 times 24 divided by 2. And when you jump to your calculator and do that, you end up with 468 square units. Final answer on that area. Now notice that all of the numbers worked out really nicely. We didn't have to do any rounding. On your quiz, you don't have to worry about simplifying the radicals here. You can round to the nearest tenth on any answer that you find along the way. Okay, good luck with your studying as always. You know that I'm available for extra help. You can email me today, or you can come and see me during advisory for extra help or after school. All right, have a good one, you guys.